Hello, Mr. Schoening here, and today I would like to show you how you're going to set up your calculated columns for the Conservation of Energy Lab. In this activity, we are going to track a basketball as it flies through the air, experiencing only the significant force of gravity, and we're trying to see what values will be conserved. And what we mean by that is it means what values will be unchanging, or in particular, which energies will be conserved as we go throughout and will remain the same value all the time. Now, we've already learned in a previous lesson that there are three types of energy that are in the mechanical category, and then there is mechanical energy itself. We have kinetic energy, potential gravity, and potential elastic, and the three of those all put together make up your mechanical energy. But in this lab, we're not dealing with any springs, so there's no elastic energy to concern ourselves with. Now, what we would like to do is to take the values that the graphical analysis program can provide for us, which are basically just positions and times. So it can take time, and it can measure the position at a given time in both the X and in the Y direction. And from those positions, we can then derive the velocities, the X velocity and the Y velocity. And now we need to turn those into energies. Now, energy is a quantity that we can't measure directly. It usually has, well, not usually, it has to be calculated from other quantities. And these quantities involve mass, and there's no way to measure mass on this video. So we need to calculate the values using a known mass. So here's what we do. If you go down here to your data table, by the way, I did collect 4 data points so that this can start to happen. What we need to do is a few things. Number one is that the X velocity and Y velocity need to be turned into a simple singular velocity. Because right now what we see is that with this projectile motion, the X velocity was constant, which makes sense. It was never gaining speed in the horizontal direction. But over here in the Y direction, it was slowing down. But the overall speed is actually combined, these two combined as a vector. So what we do here is and this is the part that you really need to follow at this point. We need to switch this velocity here, these two velocities, to an actual velocity. So what we're going to do is, and everyone must do this, click on this triple dot here, the column options. And when I click on that, I apologize for the lagginess. It's a little bit laggy because of the amount of memory being used by the programs I'm using right now. I'm going to go to Add Calculated Column. Now, this calculated column we are going to call our actual velocity. That's the combination of the X and the Y put together as a vector sum. The units are meters per second because that's what they used here. And now it says to insert an expression. Insert expression means how am I going to calculate this? And this looks a little bit weird. This is different. What we see here is that we have terms called A and B. The A's and B's are constants. The X and Y's are variables. Variables are these things that are in each column that are defined. A's and B's would just be numbers that we give for those constants. So the first thing we are looking for is the velocity. And we know that the velocity is done as the vector sum, and that's using Pythagorean theorem. And if we look right here where my mouse is at the moment, this is a pre-solved Pythagorean theorem. It's saying take the square root of the X and the Y. So we click on that, and it asks us, okay, what is the X and the Y variable that you want to use? Well, we're doing the actual velocity. So this will be the X velocity, and we also need the Y velocity. So it will do the Pythagorean theorem for these two terms. It's very important to make sure we pick those two terms. You can't just randomly pick anything. We're trying to do the vector sum of the X velocity and the Y velocity. If we do that, we will hit apply. And now we have a new column that's been created. It's called actual velocity here, and it's calculated it for us. And now it's a new variable that we can use. So the variable that we're going to want that uses velocity is the kinetic energy. So I click on this button again. I am going to select Add Calculated Column. And this calculated column is going to be called kinetic energy. And we know kinetic energy is measured in joules when we use kilograms, meters, and seconds, which we've done. And now it's time to insert our expression. Now, if we know that kinetic energy is 1/2 mv squared, and the number 1/2 is constant, and in this lab, we're going to assume the basketball to have a mass of 1 kilogram, so the mass will be constant. That means technically we have two constants that we could multiply and make one constant. So that would be A. We would have V, which is velocity, which is a variable. That would be an X, and then squared is an exponent. So we need a constant with a variable and an exponent, and that is this particular term right here. A is our constant number. X is going to be our varying number or our varying measurement, which is the name of these columns, and then B is the exponent we want to use. So we said that we're using 1/2 times 1, so my parameter A is going to be marked out as 0.5. I'm going to use my actual velocity because that's the V of the 1/2 V squared, and then the exponent, which was B, is supposed to be squared. So we're going to turn that to a 2. So we have 1/2 times the velocity squared. We hit apply, and that creates a kinetic energy column for us, and it also calculates that value, which, by the way, we see is getting smaller as time goes on. The next term that we need is we need to now look at the potential energy, or technically gravitational potential energy. I'm not going to write gravitational because I know it's not elastic, so I'll call it potential energy. That's joules. I'll hit insert expression here. And if we think about it, potential energy is mass times gravity times height. We've already mentioned that the mass is constant and the gravity is constant, so we can merge those two together as one constant. Height will vary, and there is technically an exponent of 1 with that. So we're going to actually use the same exact expression here. But this time we're going to take a mass of 1, times it by a g value of 9.8. So my constant is actually going to be a total of 9.8. It's technically 1 times 9.8, but neither changes, so it's always 9.8. We are going to be measuring the height as our variable here, which would be represented by the term y. And it should be to the first power. So we can calculate 9.8 times the y position to the first power should give me my potential energy. And we're almost done. The only other thing that's left to do is to get the mechanical energy, and by definition, the mechanical energy is the sum of the kinetic and the potentials. So I click on my trusty triple dots here, and what we're doing this time is we're just adding 2 of our columns. So if we call this mechanical energy, its unit is also joules. It is the sum of 2 variables with no constants. So I need to find variables without constants, and I look around and I scour through, and there they are. X and Y are 2 different variables here, so I'm going to pick X and Y. And the 2 things I'm supposed to be adding are kinetic energy and potential energy, and it knows to calculate these 2. We hit apply. And we finally now have our mechanical energies listed over here. So we have some values here. So the key is that was how we created it. Every time we wanted to make a new column, we used the triple dots. We had to think logically how it would go. So we picked the structure of the equation and then picked the variables and constants that we used. Now, you might realize you made a mistake with the math. Hopefully you did it. But if you did, you can fix that. For example, I didn't make a mistake with the math, but here in actual velocity, I can see I forgot to type of space. So if I click here, this is easy enough to fix. If you realize you've made a mistake, you hit column options. And when I go to column options, I can go back, I can fix the expression. If I totally pick the wrong one and realize it's the wrong one, I can hit X and start all over. And that's all you really do. You just fix them. So actually, I thought I had a mistake here with the actual velocity, but I think it may have just decided. Let me put 2 spaces and see what that does. The space seems to be there. It seemed to have contracted it into the same box, or tightly in the box. I think it may have just got rid of the space for me. In fact, let me try this instead. Let me do underscore. So it's actually a true character. We hit apply. And now we can see that edited that term right there. And that's basically it. So now what we've done is we've created our columns. The only thing that will be left is to view these columns. So what I can do is if I click over here on the graph, I will say the ones that I want to look at. I only want to look at kinetic, potential, and mechanical. And this is early in the experiment, so you're not going to see much with it yet. And we have a bunch of data points that haven't made a very good pattern yet. We've only had 4 points. But here's one cool thing also, and this is the last thing that I want to show you today. If I click on the graph here, notice what happened is that I have this line here. And as I move through the graph to each point, you'll see that the video also moves accordingly. So you will be able to answer questions about the different energies at the different locations in the video just by scanning this back and forth. Also, one final thing is if you wanted to actually have a line so you can see the trend a little bit better than some stray dots, if you click here and you do edit graph options. you also have an option to put lines on here, or even both. And if you do that, then you should be fine. And that's it for now. Okay, so make sure you calculate those columns correctly. If you need to rewind this video to see what I did, please do so. Have fun solving it, and good luck on your lab.